Hi everyone. Implementing any machine learning algorithm using library is not a complex part. But knowing the mathematics behind the algorithm is always advantage for us. So before going to start my first task, I'm going to discuss how linear regression work. Now let's start our discussion. So suppose we have a data set. Okay. So first I will give a general explanation, then I will try to connect this thing with our task one. So we have a data set, so we have to predict our yi. Okay, so based on, see, you can understand this is your output. Actually, this is your output, something based on your input. This is your input data. So based on your input data you have to predict your y, and y could be anything. Like anything means anything, that should be any real number actually. Okay, so that is the reason behind that we call it regression problem. Like y could be any real number, so that's the regression problem. And this input, like, not compulsory that it's only one input, there could be 10 input, 5 input, 6 input. So this xi just represent, this is an input, like you can understand it's a feature, or you can understand it's a variable, or you can understand it's independent things. So based on this independent things, because based on this your independent variable, you will get the output. So xi could be any number of things. Okay, this could be in d-dimensional vector, and yi is any real number. Now let's come to the problem. Let's come to the linear regression problem, how it works, and what is the aim, what is the actual task of the linear regression. Suppose you have weight. So suppose this is your input. So based on this input, you have to predict your height. How you can do it? Okay. So basically, we are greedy about to find out a function like that. So if I will give my weight as an input, I will get my height. That's neat actually. That we required. Okay, so all the machine learning algorithm do the same thing. They just try to find out the best function, and inside that function we just pass the input. That means what, we pass our feature variable, and based on those features this function will return me, this function will give me a value. This could be a classification thing, this could be regression thing actually. Okay, now let's connect this thing with our problem. Okay, so suppose we have a weight and we have a height. We have to predict this height. Sorry, we have a weight, and based on this weight we have to predict our height. So suppose we have a data set, we have a data, and inside the data we have weight and height. Okay, uh, suppose we have a data. Okay, and inside the data we have two things. Okay, this data set is, like you can understand, we have only weight column and we have a height column. Okay, so some data is given, some data is given. Suppose we have some data. So I will plot it. I will do a scatter plot of this data. Okay, I will take this data and I will plot it. So here 1 2 3 is what, it's just representing the points actually. So this point, you can understand, this is this one. So this is a one coordinate. So I'm taking weight, I'm taking weight on my x-axis, and height on y-axis. Okay, so after plotting it, like after doing scatter plot of these two things, I'm trying to find out the best fit line. What do you mean by best fit line? See, I can get thousand of line. I can get a thousand of line, but out of those line, which of the line is the best line? Okay, so see, this is the actual scatter plot. You can think like 1 2 3 just representing the points. So this is a point number 1, point 2, point 3, point 4. So let's try to find out the best fit line. So you can say this could be one line. Okay, this is just understanding. This could be another line, and suppose I am plotting it one more line. So we have this three line, but out of this three line, which of the line is the best? So let's call this L1, L2, and L3. We need a best fit line. What do you mean best fit line? Let's come with a solution. Suppose I'm using my L2. Let's suppose we have a L2. Suppose we have a 8 points. Keep this thing in your mind. We have a 8 points. Plotted it. So for this weight, suppose we announce that L2 is a baseline. Suppose we announce that L2 is a baseline. Okay, we announce this thing. Okay, suppose for this weight, this is some value. So based on this value, you said what will be the height. So this is your predicted height. And what was actual height? This was actual height. Point number two, you can understand predicted and actual both are same. So you can say y I dash and y is 0 here. Both are same actually. Okay. So for this thing, for suppose you are giving this input something, you are giving this input. So this is your, you can think this is your predicted height for this value. But actual is what? Actual is this. So this is a difference actually. This is an error. This, if this was a perfect line, okay, for the this point should be here, but this is not here. We have some error here actually. Okay, this is a, we can say it's a, like it's a problem. This is an error, you can think. So there is some error, and this could happen. Don't worry, I will get some error value. Okay, if you just observe all these three line, all this line 2 have maximum accuracy, you can see, like lots of point is on the line. If you take L1, I can just get only one value which is correctly. Okay, like this point, like this line have lots of error because he is just predicting point 1 as like a correct, but for all the point he is not going to predict correct. Okay, that means what, error is too large for this line L1, and for L2 the error is going to be the minimum as compared to the L2 and L3. So basically best fit line is what we are trying to find out, the best line which minimize the error, which minimize the error. Error means what you have predicted and what was actual, that is your error actually. Okay, so basically we squared it to just avoid the negative value, so this called square error. So that is our task. So basically line is what, so we got it. So basically line is what, basically in 2D line is what, how we get the line have an equation y is equal to mx plus c. So this line, how I can get this line or this line or this line, I have to just change my slope and intersect. If I will change my slope and intersect, I can get line. And this is actually input. This is not going to change. This thing you will get from the data set. So actually in linear regression, what we are trying to find out, we are trying to find out the slope and intersect which can reduce or which can minimize our error. So we need to find out the best line. Best line means what, we need to find out the best slope and intersect which can minimize our error, and that's the mathematics actually. So basically we want to try to find out best slope and intersect which can minimize our error per particular point. Okay, and that if we can find out m and c, we can post like y equal to mx plus c. So this formula, if suppose I got m equal to 2.3 and I got c equal to 4, suppose I got this, so I can just construct a function 2.3 x plus 4 and I can give this function to my user, and if he is going to put any value of weight, and then he will get the height. And that's thing actually, that is the actually regression thing. You are just greedy about to find out the slope and the intersect, and that slope and intersect should be like, you have to select those slope which reduce or which minimize your error, you can think like that. And you can understand error is what, suppose this is your line. Okay, so this is your point, suppose this is your actual. So if you plot it, suppose this is your actual. Okay, so for this weight, suppose this is your predicted height but this is your actual height, so this is your error. So we want to reduce it. Okay, so we want to find such line which can reduce or which can minimize the error. So suppose I have this one more line. So out of this line, this two line, which line you will select? Because this will have, like this line have less error as compared to this line. So that's the idea actually. So we are greedy about to find out the best fit line. And best fit line is what? Which minimize the error. Okay. That means what? If you are finding the line, so what's the meaning of line? For line, we need two things. We need a slope and intersect. So we are finding the best slope and intercept, which can minimize your error. That's it. Okay, so that's the idea of this thing. Okay, it's not a complex thing. So basically what is your aim? To find out the best fit line for the given data. So यहाँ पे आपने जो देखा, okay, basically here we are just exploring 2D. Okay, so it could be in ND. Okay, suppose you are exploring the ND, so instead of finding the line, you will find the best plane. You are finding the best plane. And if you are in ND, suppose you are finding the best hyperplane. So idea is simple. You are just trying to find out these two things. Okay, this is called hyperparameter. You are trying to find out this M and C. So this could change. So this is 2D only. So this is look like this. Tomorrow you will get 3D, 4D, 5D. Okay. So suppose you have something. So this is, you can understand simple. This will be weight actually. You need a weight. So suppose tomorrow your equation look like this one. Suppose your height is equal to, your equation look like that, W1 into feature 1 plus W2 feature 2 plus W0. Suppose this is a 3D. So we are greedy about this W1 and W2. We need to find out, and this one also. We need to find out these three things. Okay. And this feature you will take from your data set actually. Okay. So basically our task is to find out the best fit line. Okay, our task is to the best fit line. Okay, this simple idea which I proposed here. Okay, I'm not going so much detail in the mathematics. uh, that's it. Now we are ready to implement our code. So now we are going to implement linear regression. So we need a bunch of libraries. We need pandas, like to manipulate the data. uh, like uh, if you want to read your data also, we need a pandas actually. And for plotting and everything like that, for that things we need a cborn and matplotlib. Okay, for any numerical operation, okay, we need a numpy, so that we imported this thing. Okay, and I have written this line 5 and 7 line. This is something like suppose the new version of the pandas or some library have new version. So again and again this, if you're not writing this two lines, your Jupyter will give a warning to you that like that. So just to get rid of those things, I have written warning, and I want to ignore those things. Okay, and I've also imported my plotly, just because I want to make my scatter plot, whatever the plot I'm going to plot, that looks good, so that I'm importing this library also. Okay, apart from that things, the how I'm reading this data is the same as, and the sample solution is given. So I just use the URL. So I read this data from this URL, and then I try to read the data, what kind of data I have. So I'm reading top 10 data. Okay, and try to understand what kind of data I have. Okay, so this is the data which we have. Okay, so if you want to know how many data point we have, you can easily do the data. Just let me do it. So it is not a complex things. So this is a simple code that will tell how many data point you have. So I have 25 data points and I have two column actually. Okay, so let's comment it and make it simple idea. Okay, so sorry for this mistake. Okay, so now this thing. And apart from that things, there is a one more things we always look, that is how many null point we have in our given data set. Okay, like any kind of information you want to know. So there is one method. Pandas have the method called info. So if we just write the like your data frame into function, this info function, this will give you the, see, we don't have any null value. Okay, that's a crux idea. Okay, so that's a take a point from this function we can understand. Okay, if you want to like to know some stats, okay, if you want to know some stats, how many data, like what is the minimum value, what is the maximum value, we can use the describe. And here I'm using t to just transpose the thing. Okay, so I have two column, one is hours, one is the scores. So counting is like hours maximum 25 and score is also 25. So you can see that minimum how many hours they are studying. Minimum there, this is not a minimum, okay, mean is this one, this is a mean, is you can understand the average. Okay, this is average. So on an average they are studying 5 hours, and on average if they are, see, you will understand this thing, if this is a mean, the marks that like they are getting 51 marks. Okay, something called minimum one. Okay, so if you are studying 1.1 hours, so this is your minimum. Okay, and similarly score have like 17.0 is a minimum score. Okay, so what is the 25 percentile, 50 percentile, and 75 percentile? You can easily understand. Like 25%, see, you can read like this. So this is my simple analogy. Suppose this is 25%. So all the data, like this is saying 2.7. So all the like 20% of the data which have less than 2.7 hours, like 20% of the people are people who are studying less than 2.7 hours actually, and there is a 50% people who is studying 4.8. Okay, less than, okay, you can understand. Okay, there's a simple analogy which I can think. Okay, so that's a simple idea, and then I plot it and I try to understand. So on x-axis we have a weight, sorry, we have a score, hours, and y-axis we have a score. So you can understand if your hours is something 1 hour, so your score is 17 something, you can think like that. So if you just think it's something like data is increasing, like it have some relationship, like in linear relationship. Okay, if this is increasing and this is increasing, like you can understand if your x is increasing, like if you're increasing your number of hours, your score is also increasing. Okay, so it's a straightforward things you can understand. So your data is like it's a linear separable, uh, sorry, the linear relationship, in a linear relationship. Now come to the point. Now we understood the data. Okay, it's not a too complex data, so lots of, like, we are not going to do any, like, there is no outlier and all this stuff. So it's very simple idea. Now uh, we are ready to model our given data. So first, for that reason, I need, see, on this thing I have stored my target value, and inside that I store my what I have as an input. So you can understand, this is my input and this is going to be your output. Okay, so I take this data. So, and I, after taking the after when I took the data, I will, okay, sorry for this thing. Let's come to the point. Okay, so what I will do, I'm taking x and y. So all the, see, this is your actually number of hours, and this is your predicted value, like what will be the score of that student. So I have taken this value as in one variable and this value in the one variable. Then I will break my data set into two parts. Okay, so I will break my data set. Suppose we have a data set dn. I will break this data set into two parts. That is, one is called dtrain and second is called dtest. So I will train my model on this data set, like dtrain. And then after training my model, I will test my model, like how it good. So for that things I will use my test data. So here we are splitting our data set into 80-20 portion. So 20% of the data we are going to use for testing, and 80% of the data we are going to use for training. Okay, so here we are splitting the data. You are saying test size is 20%. Okay, and we are splitting our given thing. Okay, so you can easily understand. Then we have, see, there is very there is simple library called SQL and model selection. We have train test split method. Inside that method, if you read the documentation, you will get each and everything. What is it, what is that? Okay, test size is something you are deciding what will be the test size. So this is, there is one thumb rule that if you have more number, like if you have lots of training data, your model is going to be like good. So always keep, like, you, if you can train, like if you have more and more data, that can make your model good actually. Okay, suppose if you are going to split 50-50%, so you have very less amount of the data for a training purpose. Okay, so always keep in mind that if you have more training data, that will make your model good actually. Okay, not a perfect. Okay, it will make a good. So after training the data, we got, like, we break the data, like we got D train and Y train. So this will be the one thing. This is your training data. Okay, and this will give you test data. Okay, so I can use these green things I will use to evaluate my model performance, and this green things, sorry, this red thing I will give for I will give to the my algorithm for training. So here we are using linear regression. So what I will do, I will fit my data. Okay, what kind of data? I will just fit my training data. Okay, now this 3 to 4 lines. See, again I'm telling you, it's not a complex thing. Anyone can just if you know, if you just Google it, you'll get the library. You can use this line of the code. You have to just you have if you have understanding of this thing, it's easy, not a complex thing. Okay, after getting this, like you fit your data x10. Now your machine got the trend. Okay, so every information have been stored in the regression. Okay, so now let's come to the next point. So what we are greedy about to find out the best line actually. So this is the line which we got after training the data x10 and y10. Okay, so this is a line which we got. So this is the line we got. Then how we got the line? So simple. In the regression, so in this linear regression, we have a method called coefficient. See, you can relate this is a y equal to mx plus c. So your y is here. Your y is, you can understand this. You are finding the line. You are finding the line. Line is what you know, that mx plus c. So this is your coefficient actually. You are trying to find out the coefficient. So this is the intersect point. So there is a one thing attribute is called intercept, and attribute is a coefficient. Okay, so we are finding that this thing and this thing, and we took this thing. Okay, we plotted with respect to the x data, and we got this line actually. Okay, so now let's come to the next one. So this is something like, as I explaining the theory part, that suppose you are studying for 8 hours. Okay, so this is something your predicted score. This is something predicted score, but actually you are suppose this is your point, but this is actual score. So this is error. Okay, similarly like that, suppose you are studying for the 6 hour, and this is your predicted score, and this is also actual score. That is a good prediction, like it's the correct thing. Okay, so you can think like that. Now let's come to the some basic idea actually. So here we are just testing, we are just passing the test data, and we're predicting. Okay, we are predicting the score. Okay, so we can create a data frame for that things. Okay, easily you can understand. Here we are what we are doing. So I just copy this code from the given sample code, and I added one more line, that is the error. So y test minus y pred. I am not taking square error, I'm just taking the simple y test minus y pred. So actual actual score was 20, but our model predicted 16.8. Not a bad idea. It's okay. So error is something like this. Similarly, our model predicted 27, but actual actual was 27, but my model predicted 33. uh, Slightly not a good, but it's okay, no problem. So you can understand like this thing. And how to evaluate, like how good your model, you can use the matrix. Okay, the simple is what you can use MAE, that is a mean absolute error. Okay, so there is some simple method, and we're getting something like this. Okay, this is a simple idea actually. So can you reduce this error? Okay, so for that we need to find the best MNC. So to find out the best MNC, we have to optimize our given equation. So we can go further, and we can use optimization technique also to optimize. Like we will try to reduce this error. Okay, so that is a simple solution which we have. So hopefully you understood the concept. So I'm just trying to explain basics idea of linear regression. Hopefully you understood my task one.